Pinkamena Diane Pie, better known as Pinkie Pie, is Equestria's most cheerful, reality-defying party pony. But here's a question you probably never thought to ask. Why is Pinkie Pie pink? It might sound like an odd question, but when we take a look at Pinkie's family, her being pink absolutely makes no sense. There are the Pie parents, Igneous Rock Pie and Cloudy Quartz, who are pale, natural-toned earth ponies. Then there are Pinkie's sisters, Maud Pie, Limestone Pie, and Marble Pie, who don't resemble Pinkie in the slightest. It's clear that Pinkie Pie stands out, and over the years, it's caused many fans to speculate that Pinkie could in fact be adopted. Up until now, we've never knew enough about how My Little Pony genetics work to figure out if Pinkie, in fact, could be related to her family. However, I have formulated a series of theories based on cartoon logic, genetics, and color theory to figure out and prove that Pinkie Pie is in fact not adopted. I will be proving this not once, not twice, but 3 times with 3 different theories. The first theory will be looking into Pinkie Pie's DNA and seeing how similar her genes are to her parents. The second theory will be diving into the Pie family tree to see if Pinkie's traits come from other family members in the family tree. And the third, which was the most shocking of all, will be about Pinkie's twin sister. Brace yourselves, as this video is going to be a big one, and let me know your thoughts in the comments below. At first glance, it's hard to know where to start. Pinkie's color scheme is completely different from her family. Pinkie Pie is bright pink, while her parents and sisters are muted grays and browns. She just doesn't fit. Or so I thought. But then I noticed something, a small detail that changed everything. The purple in Maud's hair. Red plus white equals pink, and red plus blue equals purple. That means Pinkie and Maud have something in common, high levels of red. And that's when it hit me. We can decode My Little Pony DNA using the same color spectrum that makes everything on your screen come to life, the RGB spectrum. RGB stands for red, green, and blue, which are the primary colors of light. When different amounts of these colors are blended together, they make up new colors. Every color you see on your phone, TV, or computer is just a mix of these 3 color values. And guess what? Every My Little Pony character we see are on screens, and therefore made up of RGB values. By using the hex code of an RGB color as pony DNA, and the individual RGB levels of that color as different genes, we can break down the DNA of all the Pie family members to figure out if Pinkie Pie's genes are similar enough to the Pie families. If we take a look at the Pie family's RGB levels, suddenly things start to make a lot more sense. Igneous Rock Pie has his highest level as red, and his lowest as blue. Cloudy Quartz has her highest level as blue, and her lowest as red. Now, if you look at Pinkie, her highest level is red, and her second highest is blue, meaning Pinkie inherited her dad's high red levels and her mom's high blue levels. And if you notice, Pinkie's green levels are an average between her father's and mother's green level. Pinkie's green value is never lower than Igneous Rock Pie's or higher than Cloudy Quartz's green value, but rather comfortably in between. These similarities are great indicators that a pony is related to their parents and vice versa. I've tested this theory with other ponies like Twilight Sparkle and Flurry Heart. And it's clear that ponies who are biologically related to their parents share the same high and low RGB levels as their parents. Pinkie inherited her Maud's and Pa's highest levels and also inherited a balance in between of their green, which blended together resulted in the color pink. Now let's look at Maud's RGB levels. Just like Pinkie Pie, Maud has high levels of red and blue from her parents. And her green level, just like Pinkie, is an average of both of her parents' green levels. This means we finally found a consistent similarity between Pinkie Pie and her sisters. This proves that Pinkie Pie inherited her RGB levels from her parents in a very similar way to her siblings. Although this finally gives Pinkie a connection to her family, it doesn't explain one thing. How likely was it that Pinkie Pie was going to be born pink? Yes, it's in her DNA. We can see that now. But was it always possible for pink ponies to be born in this family? Or is Pinkie just a special case? I mean, we've all seen the many rare ponies who have been born in this show. There are the Cake Twins, one's a unicorn, the other a Pegasus, both born to Earth pony parents, who developed pretty powerful magic and flight early on. And there's Flurry Heart, the firstborn alicorn Equestria has ever known, and again develops extremely powerful magic and flight early on. Even the most powerful and wise ponies in this show, like Celestia and Luna, don't have a clue about how these genetic mysteries happened. I wasn't going to leave this halfway. I had to prove Pinkie could be related 100%, because unlike AJ, we've never seen Pinkie's birth certificate. Now, there's a genetics tool called a Punnett square that could help us calculate the likelihood of igneous rock pie and cloudy quartz having a pink pony based on their DNA. A Punnett square is a tool that shows how traits from parents can be passed down to their children. Each parent gives one version of a gene, and the square helps us see all the possible combinations. It's like a genetic guessing game, and it shows which traits are more or less likely to appear in the next generation. Two capital letters like RR or GG are going to represent high levels of color in a gene, like Pinkie having a red value of 254 for her red gene. Two lowercase letters like RR or BB will represent a pony having low levels of color in a gene. A good example of this would be Princess Luna having a red value of 54. And finally, one upper and one lowercase letter like GG or BB represents medium levels of color in a gene. A good example of this would be Limestone Pie's green value of 158. I used the chart below to divide pony RGB values into low, low to medium, medium, medium to high, and high levels. First, let's focus on the red gene, the R in RGB. Igneous Rock Pie's red value is 199, meaning his red value falls into the medium to high category. Cloudy Quartz's red value is 215, which means her red level is also in the medium to high range. Now let's create the square. Per this square, there is a 25% chance of a low red level pony, a 25% chance of a high red level pony, and a 50% chance of a medium red level pony. Now let's look at the pie children. Pinkie's red value is 245, meaning she has high red levels. The red value for Limestone Pie is 158, which means she falls into medium levels. Maud and Marble Pie's red level is 194, which falls into the medium to high category. To accurately represent this, we will be giving both of them the medium and high level genotypes. Pinkie's red levels have a 25% probability of existing. Limestone Pie's red levels have a 50% probability of existing. And Maud and Marble's red levels have a 75% probability of existing. Now, let's move on to the green gene. Igneous Rock Pie's green level is medium level, and Cloudy Quartz's green value is medium to high. When we make the Punnett square, we can see that there's a 25% chance of a high green pony, a 25% chance of a low green pony, and a 50% chance of a medium green pony. Pinkie, Maud, and Marble have medium to high levels of green. Therefore, when we add the medium to high probabilities, we get a probability of 75% chance of existing. Limestone has medium green levels, so her probability would be 50%. Finally, let's tackle the blue gene. Igneous Rock Pie's blue level is low to medium, and Cloudy Quartz's blue level is high. When we make the Punnett square, we can see that there is a 50% chance of a high-level blue pony and a 50% chance of a medium-level blue pony. Pinkie Pie is a high blue-level pony, so her probability for this gene would be 50%. Maud, Limestone, and Marble Pie's levels are medium to high, so their probability would be 100%. So far, we've collected the individual probabilities for each gene. Now let's put it all together. When we combine Maud's, Limestone's, and Marble's probabilities together, we get 56.3% probability for Maud and Marble existing, and a 25% probability for Limestone existing. Now, let's take a look at Pinkie's probability. When we put Pinkie's high red level, high blue level, and medium to high green level together, we get a total probability of 9.4%. So there is only a 9.4% chance of igneous rock pie and cloudy quartz having a pink pony. This is further supported by the fact Pinkie was actually named after her grandmother, Pinkamena. This means there has at least been one other pink pie. And although 9% is very little, for a birth to be considered rare, it needs to be less than 5%. So Pinkie is rare, but not exactly by scientific terms. But this left me wondering about Marble Pie, who is Pinkie's younger twin sister, and how she could have impacted Pinkie Pie before being born. In the episode Heartbreakers, Pinkie mentions she was born 53 seconds before Marble, indicating that they are twins. I genuinely believe Marble Pie and Pinkie Pie affected each other genetically before being born, because Marble Pie's gene levels are the literal inverse of Pinkie Pie's, which is just so fascinating. There's a separate branch of biology that shows how human twins can affect each other and how sharing resources before being born could alter appearance. Now, this video is getting quite long already, so I've decided to make a separate twin theory video. This video is the second part to My Little Pony Genetics series. You can watch the first part right here. And get excited, because the next video in the series will be about the rarest My Little Pony combination, where I'm going to figure out what the rarest pony in My Little Pony would look like. If you like this video, make sure to subscribe and like this video, and let me know your thoughts in the comments below. I'll be sure to reply to everyone. I hope you enjoyed the video and have an awesome day. If you'd like to watch the crazy world of pony genetics, then click here.